Hello, welcome to the office hour. Today we are going to take a look at our result from strict isolation that we did on Thursday. Now it's Sunday, so it's been about 3 days. Actually, I went back to the lab on Friday, which is a day after about 24-hour incubation. There was nothing growing yet at that time. So just a recap, on Thursday we did strict isolation of 6 different probiotics, yogurt, things like that. And for each product, we did strict isolation in 2 different plates. Why did we do 2? Because one of them were incubated at 37 degrees Celsius, which is similar to human body temperature, and the second one were incubated at the room temperature. So when I came back on Friday, there was nothing, so I didn't make the video. But now Sunday, let's see. It's been 3 days, it should grow by now. If you want to check out how I did the strict isolation, check out the video on Thursday. I put the link in the description below. But for now, let's check our result. Before we do any sort of laboratory work, it is always a good idea to put on your PPE. So what is PPE? PPE stands for Personal Protective Equipment. This includes lab coat, gloves, or any other necessary equipment, protective equipment, depending on the nature of your laboratory activity. So let's get our PPE. I got my lab coat next to me. Now, when you're wearing lab coat, it is important that you actually button up your lab coat. Why is that? I mean, it may look cool with the open lab coat like this, like that, But the thing is, if you walk around with this dangling cloth and you walk around in the lab, you may accidentally swipe all these bottles or any laboratory tools in the lab, and that may cause accidents. So it is not a good idea to leave the lab coat open. So let's just button it up. And of course, we have our gloves right here. Now we're ready to take a look at our result. So let's go. We got the incubator back there. I'm going to take a look at, see what we got. Okay, let's go. All right, so here are the result from our strict isolation. This one is actually pretty chill because the room is kind of cool. These are the one from the room temperature. This one is a little bit warm because this one coming up from the 37 degree incubator. So it looks like from our room temperature, there is no growth still. So you can see from here, there's nothing there. There's nothing here. Nothing here, so it doesn't seem to grow for now. And then the other one, also there's nothing growing here. There's nothing growing here, nothing growing here. Well, I mean, you can see the quadrant 1, there's some growth, but that's because we put the yogurt there, right? So of course, expect something there. Now, let's take a look at this. Wow, so it looks like this is the Giovanni yogurt. So you can see, look at this, right? And this is a really nice 4-quadrant isolation. And that's actually the reason why when I teach my class, I always recommend my student to do 4-quadrant strict isolation, because in my experience, that gives them the most chance to get good isolation, something like this. And this looks pretty, but there are other strict isolation techniques out there. My favorite is the Serpentine Streak because it's pretty quick and dirty, very fast, but oftentimes you don't get this really nice and beautiful result. Look at this, everything, so each line are separated, right? And you can see there's a quadrant 1, quadrant 2, that's quadrant 3. By quadrant 3 you already start to get isolation. Look at that. See that little dots, those are the colonies right there. And each colony arises from a single cell. Remember, as you go from quadrant 1 to quadrant 2, you lower the cell density. But nevertheless, it's still a lot. You can see You can see from here, it's still quite a lot, right? But once you go to quadrant 3, from quadrant 2, you lower it even further. So at this point, you can see some of these microbes, you lower the cell density enough to the point that they are somewhat separated into an individual cell, and each cell will divide, grow and grow and grow after you incubate them for 3 days to make this visible mass that you can see with your naked eye, and that's what we call the colony. Okay, now what do you call that individual cell that started the colony? Guess what? It's very simple. It is called the colony forming unit, or CFU. Okay, so when you talk about CFU, you're talking about that individual one cell that initially land on your agar, and when it grow after you incubate them for some time, they form this visible mass. That visible mass is no longer called CFU. We call that colony. But oftentimes the colony is a proxy to estimate how many cells or how many CFU you have initially. So more on that later when we talk about serial dilution, perhaps sometimes in the future. Okay, so nevertheless, if you look at here again, the quadrant 1, quadrant 2, here you have quadrant 3. Look at that, they're growing nicely, and because we separate them enough, by quadrant 4 there's already nothing there because you already lower the cell density sufficiently well. Okay, so here's another one from Yakult. Yakult, there's nothing growing for now, so you can see there's that growth in quadrant 1, but that's potentially from our yogurt. But you see nothing there. Okay, so far Yakult is a no-go. What about Yakult? Yakult claimed they have a lactobacillus something, I don't remember, it's just over there. But look at this also has growth. Look at that, there's a quadrant 1, quadrant 2, there's some separation, quadrant 3, and then by quadrant 3 you get that isolated colonies already. So this is really good, and some have the quadrant 4, but largely they are empty because we separate them enough. Okay, let's see what else we have. Lala yogurt smoothie. There's nothing growing in here, so far again still nothing growing. So I'm gonna I'll put everything in the incubator for 1 more day or maybe 2 more days. We'll see if it can grow. Lucerne, here's also Lucerne. This is another yogurt brand. You can see something is growing, but they're very tiny. Look at that. Those are very tiny cells. Okay, they start to grow, but they're very slow. Okay. All right, so let's just put them to grow for 1 more day or a few more days or so. Oikos, look at this oikos right here. Also have the plate is kind of wet, has a lot of moisture, but nevertheless you can see there's a quadrant 1, quadrant 2, and then you start to see separation on quadrant 3. So that's how you know your strict isolation works very well. Okay. Now, the big question that you may ask. So, you have some probiotic product where there is no bacteria growing on it. Does that mean the company is lying to us? The answer is no. Well, at least we don't know. And the reason for that is because different microbes, they require different condition for growth. They require nutrients. Okay, so some require slightly acidic condition, so in that case you may need to make lower pH agar. Our agar is just a standard nutrient agar, pH about pH 7 or so, 6.9 to 7.1 or so. It's possible that the microbes are not doing too well in that pH, right? Or if you need some other nutrients requirement. Of course, we don't know. It may be the trade secret of the company who produced the yogurt. Of course, we may never know unless you ask them. Another thing is the temperature. Okay, so here we don't know what temperature works best. I somewhat just assume, well, if the microbes need to survive in the human intestine, because that's essentially what we want from the probiotic, right? You want to ingest something and the microbes can populate your gut, so you can expect they grow at the optimum temperature of 37 degrees Celsius, right? But who knows, right? Maybe their optimum temperature is slightly less, maybe, who knows, right? So there are a lot of things, a lot of variables that we don't know. This is just a quick and dirty method to look at these microbes. Another possibility is perhaps the microbes simply grow slower, right? This one, we incubate them for 3 days. Maybe you need to incubate them longer, especially in the non-ideal condition. Like, but yeah, maybe they prefer lower pH, and then you force these microbes to grow at higher pH, and they don't like it, so they tend to grow slower. Maybe that's also a possibility. So there are a lot of things that comes into play when you are looking into isolating microbes. In fact, one of the challenges to characterize all microbes in the world is that many of them we cannot culture. We simply don't know how to grow them in the lab. And that's why we've heard about the thing called metagenomic, where people just go collect soil samples, seawater sample, and simply look at the DNA and see what microbes are in that sample, even though we cannot culture every single one of them. Well, I hope you learned quite a few things, strict isolation, and meanwhile have fun with it. I think that's one of the things that people sometimes forget. Science is fun, right? It may be difficult. People often associate science courses with a hardcore, difficult class, but it's actually quite fun. Okay, it's a way for us to understand how the world works. For those of you who love science, good for you, but always remember to have fun. Okay, well, I guess that's pretty much it. Don't forget to hit the like button, and if you feel that the video in this channel is interesting to you, consider to subscribe. And I guess that's it. I'll see you guys in the next office hour.